Nathan Odie asks, what are the strongest common themes between the current state of AI and Web 1.0? And so let me start there. Let me give you a theory, Ben, and see what you think. So I get this question, because of my role, and Ben, you with me at Netscape, we get this question a lot because of our role early on with the internet. And so then there's the internet boom was like a major event in technology, and it's still within a lot of people's memories. And so the sort of people like to reason from analogy. So it's like, okay, the AI boom must be like the internet boom. Starting an AI company must be like starting an internet company. And so what is this like? And we actually got a bunch of questions like that, that are kind of analogy questions like that. I actually think, and then Ben, you and I were there for the internet boom, so we lived through that, and the bust, and the boom, and the bust. I actually think that the analogy doesn't really work for the most part. It works in certain ways, but it doesn't really work for the most part. And the reason is because the internet was a network, whereas AI is a computer.
Yep.
Okay, yeah. So people understand what we're saying. So the internet,
like the PC boom,
or the PC boom, or even I would say the microprocessor. Like my best analogy is to the microprocessor.
Yeah.
Or even to the original computers, like back to the mainframe era.
Mm-hmm.
And the reason is because, look, what the internet did was the internet, obviously was a network, but the network connected together many existing computers. And then, of course, people built many other new kinds of computers to connect to the internet. But fundamentally, the internet was a network. And then, and that's important because most of the sort of industry dynamics, competitive dynamics, startup dynamics around the internet had to do with basically either building networks or building applications that run on top of networks. And this, the internet generation of startups was very consumed by network effects. And all these positive feedback loops that you get when you connect a lot of people together, and things like so-called Metcalfe's law, which is sort of the value of a network, expands, kind of the way it expands is you add more people to it. And then there were all these fights, all the social networks or whatever fighting to try to get network effects and try to steal each other's users because of the network effects. And so it was kind of it's dominated by network effects, which is what you'd expect from a network business. AI, like there are some networks effects in AI that we can talk about, but it's more like a microprocessor. It's more like a chip. It's more like a computer, in that it's a system that basically, right? It data comes in, data gets processed, data comes out, things happen. That's a computer. It's an information processing system. It's a computer. It's a new kind of computer. It's a we like to say the sort of computers up until now have been what are called von Neumann machines, which is to say they're deterministic computers, which is they're like, hyper literal, and they do exactly the same thing every time. And if they make a mistake, it's the programmer's fault. But they're very limited in their ability to interact with people and understand the world. We think of AI and large language models as a new kind of computer, a probabilistic computer, a neural network based computer, that, by the way, is not very accurate and is, doesn't give you the same result every time. And in fact, might actually argue with you and tell you that it doesn't want to answer your question.
Yeah. Which makes it very different in nature than the old computers. And it makes it kind of composability, the ability to build big things out of little things, more complex.
Right. But the capabilities are new and different and valuable and important because it can understand language and images and, all these things that you see when you use
all the domains we could never solve with deterministic computers we can now go after. Right.
Yeah, exactly. And so I think, Ben, the analogy and I think the lessons learned are much more likely to be drawn from the early days of the computer industry or from the early days of the microprocessor than the early days of the internet. Does that sound right?
I think so. Yeah, I definitely think so. And that doesn't mean there's no boom and bust and all that, because that's just the nature of technology. People get too excited and then they get too depressed. So there will be some of that, I'm sure. There will be over build outs, potentially eventually of chips and power and that kind of thing. We start with the shortage, but I agree. I think networks are fundamentally different in the nature of how they evolve than computers. And the kind of just the adoption curve and all those kinds of things will be different.
Yeah. So then, and this kind of goes to how I think the industry is going to unfold. And so this is kind of my best theory for kind of what happens from here. This kind of this giant question of is the industry going to be a few God models or a very large number of models of different sizes and so forth. So the computer, famously, the original computers, like the original IBM mainframes, the big computers, they were very, very large and expensive, and there were only a few of them. And the prevailing view, actually, for a long time was that's all there would ever be. And there was this famous statement by Thomas Watson Sr., who was the creator of IBM, which was the dominant company for the first 50 years of the computer industry. And he said, I believe this is actually true. He said, I don't know that the world will ever need more than 5 computers. And I think the reason for that, it was like the government's going to have 2, and then there's like 3 big insurance companies, and then that's it.
Yeah. Who else would need to do all that math?
Exactly. Who else needs to keep track of huge amounts of numbers? Who else needs that level of calculation capability? It's just not a relevant, it's just not a relevant concept. And by the way, they were like big and expensive, and so who else can afford them? Right. And who else can afford all the headcount required to manage them and maintain them? I mean, and this is in the days, these things were big. These things were so big that you would have an entire building that got built around a computer. Right. And they'd have they'd famously have all these guys in white lab coats, literally like taking care of the computer, because everything had to be kept super clean or the computer would stop working. And so, it was this thing where, today we have the idea of an AI God model, which is like a big foundation model. That, then we had the idea of like a God mainframe. Like there would just be a few of these things. And by the way, if you watch old science fiction, it almost always has this sort of conceit. It's like, okay, there's a big supercomputer, and it either is like doing the right thing or doing the wrong thing. And if it's doing the wrong thing, that's often the plot of the science fiction movies, is you have to go in and try to figure out how to fix it or defeat it. And so it's sort of this idea of like a single top-down thing. Of course, and that held for a long time. Like that held for the first few decades. And then even when computers started to get smaller, so then you had so-called mini computers was the next phase. And so that was a computer that didn't cost $50 million. Instead, it costs $500,000. But even still, $500,000 is a lot of money. People aren't putting mini computers in their homes, and so it's like mid-sized companies can buy mini computers, but certainly people can't. And then, of course, with the PC, they shrunk down to like $2,500, and then with the smartphone, they shrunk down to $500. And then, sitting here today, obviously, you have computers of every shape, size, description, all the way down to computers that cost a penny. You've got a computer in your thermostat that basically controls the temperature in the room, and it probably cost a penny, and it's probably some embedded ARM chip with firmware on it. And there's many billions of those all around the world. You buy a new car today, it has something. New cars today have something on the order of 200 computers in them, maybe more at this point. And so you just basically assume with the chip today, sitting here today, you just kind of assume that everything has a chip in it. You assume that everything, by the way, draws electricity or has a battery because it needs to power the chip. And then increasingly you assume that everything's on the internet, because basically all computers are assumed to be on the internet, or they will be. And so as a consequence, what you have is the computer industry today is this massive pyramid, and you still have a small number of like these supercomputer clusters or these giant mainframes that are like the God model, the God mainframes. And then you've got, a larger number of mini computers, you've got a larger number of PCs, you've got a much larger number of smartphones, and then you've got a giant number of embedded systems. And it turns out like the computer industry is all of those things. And what size of computer do you want is based on what exactly are you trying to do, and who are you, and what do you need? And so if that analogy holds, it basically means actually we are going to have AI models of every conceivable shape, size, description, capability, right, trained on lots of different kinds of data, running at very different kinds of scale, very different privacy, different policies, different security policies. You're just going to have like enormous variability and variety, and it's going to be an entire ecosystem and not just a couple of companies. Yeah, let me see what you think of that.
Well, I think that's right. And I also think that the other thing that's interesting about this era of computing, if you look at prior eras of computing from the mainframe to the smartphone, a huge source of lock-in was, basically the difficulty of using them. So, nobody ever got fired for buying IBM because you had people trained on them, people knew how to use the operating system. Like it was just kind of like a safe choice due to the massive complexity of like dealing with a computer. And then even with the smartphone, like why is the Apple computer smartphone so dominant? What makes it so powerful? It's because like switching off of it is so expensive and complicated and so forth. It's an interesting question with AI, because AI is the easiest computer to use by far. It speaks English. It's like talking to a person. And so like, what is the lock-in there? And so are you completely free to use the size, price, choice, speed that you need for your particular task, or are you locked into the God model? And I think it's still a bit of an open question, but it's pretty interesting in that thing could be very different than prior generations.